Yes, welcome to this session. So now we go to the Lagrange linear equations. So the first order linear partial differential equation is of the form. So capital P small p plus capital Q small q equal to R. Suppose given partial differential equation is of the form. So then we call as that equation is Lagrange linear equations. So here capital P, capital Q, capital R are functions of x, y and z. So we go to solve the Lagrange linear equations. First we want to form the subsidiary equation or we call as auxiliary equations. So the subsidiary equation is of the form so dx divided by p plus that is equal to dy divided by q that is equal to dz divided by r. So what is the working rule means? So write down the subsidiary equations dx by p, so dy by q, dz by r. So this p is nothing but coefficient of small p in the given equations. Q is equal to coefficient of small q and r is nothing but the remaining in your RHS. So let uh, solve the above subsidiary equations. We can get two solutions u and v. So the general solution of given PD is of the form f of u comma is equal to 0. So replace our u and v, we can get a solution. This is the working procedure. So generally the subsidiary equations can be solved by any one of the following two methods. The method one is method of grouping, method two is method of multiplier. So method of grouping means nothing but in the given auxiliary equations, if the variable can be separated in any pair of equations, then we can get a solution is of the form u of x comma y comma z equal to c1 and v of x comma y comma z is equal to c2. In method of multipliers, choose any three multipliers L, M, N, which may be constant or functions of x, y, z. So we have dx by p, dy by q, that is equal to dz by r. So these ratios are which is equivalent to so L dx plus M dy plus n into dz whole divided by L into p plus m into q plus n into r. Therefore, we can choose the element such that L into P plus M into Q and N into R should be 0. If you chosen that kind of element, then we can equating 0 in the numerator. So that is L dx plus M dy plus N into dz is equal to 0. If L dx plus M dy plus N dz is an exact differential, then on integrating we get a solution u of x comma y comma z is equal to c1. So here the element is the multiplier are called Lagrange multipliers. So problem number 1, solve px square plus qy square that is equal to z square. So take the given partial differential equation as equation number 1. So since this is of the form capital P small p plus capital Q small q is equal to R. So here the coefficient of small p is capital P, coefficient of small q is equal to capital Q. So the remaining in your RHS is your R. So therefore capital P is nothing but x square, Q is equal to y square and R is equal to z square. So this is our subsidiary equations. So therefore already we know the values of P, Q, R. Replace it. So capital P is nothing but x square, capital Q is equal to y square, capital Z is equal, capital R is equal to z square. So now I can able to choose a consider 1 and 2. So we can able to separate the variable. So I can choose these ratios. And second ratio is whether we can choose dx dy or uh, sorry dx dz or dy dz. Here I can consider the second and third dy dz. So now in integrating the both the sides, so we can get integral of 1 by x square into dx, that is equal to integral of 1 by y square into dy. I bring this x square in the numerator, so we can get x power minus 2. Similarly, I bring this y square in the numerator, we can get y power minus 2. Therefore, now we can use the formula integral of x power minus 2 into dx is equal to x power minus 2 plus 1 divided by minus 2 plus 1. Similarly, integrating the right hand side, we can get this. Simplify this, we can get this 1 by y minus 1 by x is equal to c1. So, which is our first solution u. Similarly, our integrating the second part, so we can get integral of 1 by y square into dy, that is equal to integral of 1 by z square into dz. So integrating the both the sides and to simplify this we can get, so 1 by z minus 1 by y is equal to c2, so which is the second solution. Hence the general solution is of the form f of u comma v equal to 0. So instead of u I go to replace 1 by y minus 1 by x with the first solution u. Instead of v I go to replace the second solution 1 by z minus 1 by y equal to 0, where f is arbitrary. So which is the general solution of the given equations. So the next problem, solve p into root x plus q into root y plus that is equal to root z. So the given partial differential equation is this. So which is of the form capital P small p plus capital Q small q equal to r. Therefore, which is, if it is given equation is of the form, means the form we call as the Lagrange linear partial differential equations. Therefore, our coefficient of small p is our capital P. Therefore, capital P is equal to this root x. Similarly, coefficient of small q is capital Q. Therefore, root y is your capital Q and RH is your R. Capital R is equal to root Z. Therefore, replace that PQR in a subsidiary equation, we can get this. Again, similarly, we can consider ratio 1 and 2. So, we can get this. Again, I can consider ratio 2 and 3, we can get this. So, both the cases are variables are separated. So, therefore, integrating both the sides. So, and simplify that one, we can get the first solution u and v. Our u is nothing but root x minus root y. V is root y minus root z. Therefore, general solution is of the form f of u comma v equal to 0. So, replace our u and v, we get the solution. So, the next problem. So, p into tan x plus q into tan y, that is equal to tan z. So, this is the equation is of the form Lagrange linear PDE, that is capital P small p plus capital Q small q is equal to r. So, therefore, here capital P is our tan x, capital Q is coefficient of small q, that is tan y, and r is equal to z. Replace it here. So, we can get the ratios. So, now we can consider the two ratios. So, first and second ratio we can consider, and second and third ratio we can consider for the solution of the second one. So, now integrating the both the sides and simplify this, we can get, so sin x divided by sin y is the first solution. Sin y divided by sin z is the second solutions. Hence, the general solution is f of u comma v equal to 0. Replace our u and v, we can get a solution. Next example 5. So pyz plus qzx is equal to xy. So this is of the, take as equation number 1. So this is of the form capital P small p plus capital Q small q is equal to r, which is called Lagrange linear partial differential equations. Here capital P is nothing but y z, capital Q is equal to zx, and xy is our capital R. So these are subsidiary equations. So replace our capital P small capital Q and capital R in a subsidiary equation. So we have to consider the ratios, the ratio 1 and 2. This is, we can consider the ratio 1 and 2. This is a ratio 2 and 3. Now here I need to separate the variables. So before that I can able to cancel this z and z. Similarly for here x and x I get cancelled. You cross multiple this, so we can get we can separate the variable. We can cross multiple this. We can get this. Now integrating the both the sides. So to simplify that one, we can get two solutions u and v. So hence the general solution is f of u comma v equal to 0. Replace our u and v, we can get our solution where f is arbitrary. Next problem, solve y square p, that is minus x y cube, that is equal to x into z minus 2y. So take that as an equation number 1. So this is of the form capital P small p plus capital Q small q equal to r. So therefore the given equation is Lagrange linear partial differential equations. So the coefficient of small p is our capital P, therefore y square is capital P. Coefficient of small q is our capital Q, therefore minus xy is our capital Q. So which is in the right hand side is our capital R. So capital R is equal to x into z minus 2y. Therefore now we can consider the subsidiary equations. Our subsidiary equation is dx by p dy by q, that is equal to dz by r. Replace p q r, we can get this. Consider the ratio 1 and 2, we can get this. Consider ratios 2 and 3, we can get this. Now here the y square and y get cancelled, we can get this part. Similarly for in another part, this x and x get cancelled. So we can get this one. So here I cross multiple this both the cases, we can get this. So take integration on both sides. Integrating it, we can get rearrange this one. We can get x square minus y square is equal to c1, which is the first solution. Similarly, here I can cross multiple this. We can get this, and I have to multiple and rearrange this. We can get in this part. So this is nothing but already we know that one differentiation of uv is equal to u dv plus v into du. So therefore, here u, this is a, that is our u, y is our v means, so u dv u dv minus v du, in this case u dv minus v du. So z dy minus y is z dz, therefore nothing but d of u comma v, we can write in the form of d of u comma v, that is d of y comma z. Therefore integrating both sides, integration and differentiation would get cancelled, therefore simply y is z, differentiation of y is y square by 2. So numerator 2 and denominator 2 get cancelled, we can get simply y square. So we can bring this y square another side, we can get this. So therefore this is the second solution, we can take as v. Now we can replace u and v, so we get a solution. Thank you.